Hello and welcome to this guide to MANIC, a dual channel VCA with superpowers that I've made with Apollo View Modular. And although we're focusing on MANIC here, this is really a guide to voltages and sound synthesis in general. You can apply the ideas in the tutorial here to lots of different modules, so join us for this video going from basic to advanced functions and the uses of VCAs, going through zero with bipolar VCAs, clipping, patching in stereo, wave shaping, wave folding for audio and CV and more. Here's what's to come. Before we get to the patches, which are module agnostic, you can apply them to lots of things. Let's just have a quick rundown of MANIC, because that's what we're using here, and everything applies to guiding you through the functions of the module. MANIC is a two-channel device, where the left-hand controls and top row here are channel 1, and the right-hand controls and the bottom row are channel 2. At the core of MANIC, like many modules, even if they're kind of hidden away in the background, are VCAs. We have manual level controls for the VCAs on the sliders, a modulation input with an attenuverter to scale and invert a modulator signal. We have the VCA input, modulation input, and the clean VCA output. Each VCA can be unipolar, like a standard VCA, or we can make them bipolar by switching down there, which will take them through zero, which means they act like a ring modulator where a negative modulation signal can invert the input. And we'll learn how that works and how to use it in this video. On MANIC, the clean VCA output then feeds waveshaping circuits, selected by the shape switch on each channel. With the shape switches in their mid positions, these are inverted versions of the clean outputs, and then on channel 1 switch up we have a tan style soft clipper, and switch down we have a surge style wavefolder. On channel 2 we have a hard clipper in the up position, and a Buchla style wavefolder on the bottom position. And while these shapers are all different, they've been tweaked to work for an enhanced stereo image for stereo inputs, or mono in to stereo out patching. So that's MANIC in a nutshell. It's a highly flexible precision building block for lots of functions, sounds and CV processes. But as I said at the start, the way that all these things work, VCAs going through zero for ring modulation style bipolar VCAs, wavefolding, inversion, voltage sources, symmetry controls, and clipping, these all apply to lots of other modules. So I hope you enjoy this video going through the functions of MANIC, whether it's for MANIC or other things that you have in your system. All the patches are on screen and in the timing index down below. I spent a long time on that timing index, so do skip around as you like, and let's dive in. So as a quick guide to MANIC and how it functions, let's start by looking at how VCAs work and the basic use of VCAs. I have a triangle wave from this oscillator, green trace and green cables, patched into the input of MANIC, and the output here, yellow trace, yellow cables, is coming into the scope, and that's what we're listening to in my mixer. This channel is set to be a unipolar VCA, which is a standard VCA, and the input bias will simply turn up the sound as any VCA with a manual control would do. Now the most common use of a VCA is to control the level of an audio signal with an envelope. The blue trace here in cables is my envelope. I'll patch that into the modulator, turn up the modulation amount, and we've shaped our incoming audio sound with an envelope. We can invert this modulation on MANIC, so if I started with the signal up, and inverted the envelope, meaning apply a negative version of this signal, taking us from our manual level down and back up again. And this is good for creating sidechain signals and things that duck against other parts of a patch. Now each channel of Manic also has a shape output, and patching across the shape here, this is a three-way switch, where in the mid position we simply get a signal inversion, so it's the same as the output, but inverted. We don't hear that in the audio sound. That could be important to your patch for audio and more drastic with, say, CV. We have a clipper, which is a tan shape, soft clipper in this case. And we have a wavefolder. And the way we modulate these shapes is simply to modulate the level. Just like on the clean output, where adding the envelope makes the level go up and down, wave shapers are typically affected by the level of the incoming wave. So if I patch into the shape output, set it to clip and turn up the envelope, we're pushing into that clipping. Likewise for the folder, let's actually set some manual level here, and then add a bit of modulation. So setting this in a more musical context, let's say clip it, add a volt proctive signal to my oscillator, and some drums. That's a quick look at VCAs for audio and the basics of Manic. VCAs and wave shaping aren't just meant for audio, they can be used with CV too. So here I have a simple triangle LFO, yellow trace and cables as my input. I have a slower triangle LFO, the red trace, red cables, that's my modulator. And then the main output is the green trace and the blue output is the shape output. I've overlaid them here because the shape output is set in its mid position, which is an inversion, so it's the same as the clean outputs here, but an inverted version. And I'm using these two outs to modulate these two filters. The green trace modulates the left side, and the inverted version, blue trace, modulates the right. So these are going up and down like a stereo tilt or a pan effect. And just having an inverted version of a signal is useful for things like this, having an inverted behaviour happening, in this case in a stereo patch. If I remove my modulation, let's even just unplug it. This is set to be a unipolar VCA, no signal coming through, just increasing the LFO level. Hopefully you can hear that inversion effect really clearly, opening and closing these two filters. Now by modulating the level of this LFO with another LFO, turning up the modulation, we have a more dynamic and interesting effect with modulated modulation. Now while doing this, we could add some wave shaping, changing this inverted output on the right hand side of the filter to say a clipper. And hopefully you can see in here this is skewing to the right now, that right hand modulation, again blue trace and cables, is a more clipped square-like version of that triangle LFO. If we were to fold it, even without any modulation, let's then add some modulation. You can hear how this triangle is folding back on itself, increasing the LFO rate and giving this interesting stereo image where the right hand side wobbles faster than the left. But you don't just have to use two LFOs here. I've changed the scope to move a bit faster and repatched in an envelope this time as my red cable and trace modulator to bring in the effect of this LFO over time. And I'll move to a faster LFO where this will be more obvious. And you can do things in your patches like using the same envelope that's bringing in this LFO and letting it come out to modulate my filter here through Manic. We could use that to actually modulate the rate of my LFO module, which I'm just patching in off screen. Now, processing and generating CV with Manic is something we'll look at in more depth in a future video. Leave any questions and comments on this one, as that can influence what comes and things we talk about and demonstrate in the future. One of the great things about modular synthesis is the ability to audio rate modulate, and to be able to do that on a wealth of parameters. If we use a VCA, we have AM, amplitude modulation. And here we're going to look at the differences between AM and RM, or amplitude modulation and ring modulation, by looking at the differences between the unipolar VCA setting and the bipolar VCA setting on Manic. I have two oscillators, two sine waves, green and blue traces as the input and the modulator here. I'm in unipolar mode. As I turn up the bias, we pass our input, and we can add the modulation. And this waveform's moving around relative to the tuning of the modulator and the input. But before we look at different tunings and kind of classic AM or RM tones, I want to first just go through the difference between the two. When the VCA is off, so think of this like 0 volts, we can't modulate with a negative voltage in a normal unipolar VCA. You can't go through 0, you can't invert a signal with a negative voltage. And here on Manic and other VCAs, it's the sum of the manual bias and the modulation. This is what controls the level of the signal. So with the bias all the way down, this is already 0, we can't go through 0, so what we get is a waveform that's heavily clipped off at 0, and the red trace there is 0 volts, the yellow trace is the output that you can see moving around it. However, in bipolar mode, which works like a ring modulator, if I move the input bias to its 0 position for bipolar, which is then the middle of the slider, and then I modulate, you can see the whole wave now goes up and down, and it will invert. If I quickly move between 0 bias and unipolar mode, and then 0 bias in the middle and bipolar, you really see the difference. Let's tune up the modulator here. And we can add some manual gain so that the negative voltages do have some level to pull down. And this brings back in more of that input waveform. The fizziness and those hard edges are where it clips off at 0, resulting in some interesting additional harmonics. But you can get rid of them, offsetting the signal, and then modulating from the level already been up. If we go into bipolar mode, we can start at 0, no level, and modulate both positively and negatively. And you can then use that input bias to push through ring modulation into AM, bringing in more of that fundamental tone. Now just a few more sweeps here in normal unipolar mode, and then some ring mod. Now the beauty of Manic is you can do all of this and feed the wave shapers. So the shape output, here's ring modulation into clipping. And a more musical tuning between the two sine waves. ability in that ring mod, that bipolar VCA, to push that fundamental back in works really well. Unipolar AM. Let's swap from a clip to a fold. And a ring mod to a fold. And as we have two channels, let's do this in stereo for one of my favorite kind of stereo universal oscillator expander patches. So here's a real favorite, which is taking a single oscillator and treating Manic almost like a stereo expander for any VCO. My input will be a sine wave here, it's the green trace, green cables. The modulator is the sub from the same oscillator, blue trace, blue cables. These signals normalize down to the second channel, so channels 1 and 2 have the same input and same modulator. And I'm coming out in stereo with channel 1 and 2 as the red and yellow traces and cables, and I'm treating them as hard left and right straight into my mixer. So I patch across to the shape outs. These are both set to clip. Let's try a -2 octave sub or a -2 pulse. Looking at the scope, it's almost like we're drawing the waveforms in search of these new stereo tones. Let's tune a little lower with a -1 octave sub. Let's try folding. So ring modulation in stereo into two different folders. Again, different sub. Loads of interesting sounds. So treat Manic as a stereo wave shaper and expander. Try ring mod with one oscillator and different outputs and subs. You're bound to find a whole world of new tones. At the input of channel 1 on Manic here, we have a normaled 5V voltage source. In the unipolar VCA mode, that gives us a 0 to 5 voltage source to patch around a system if you don't plug in a cable that removes that normaled signal. Here I'm using the input bias slider to take us from 0 volts to 5 volts as a performative control in my patch. I have the voltage here on data, it's all blue cables here for you to follow, and then that patches out into the rate of the LFO that controls my PWM. A copy also opens up the filter for my riff, and another copy comes down and adjusts the mix level from dry to wet on my delay. Another interesting use of this normaled voltage here is to use it as a symmetry control for the wavefolders on Manic. So let's repatch and check that out. So let's use the idea of an offset voltage as a symmetry effect for the wavefolder. But first let's take a look at how this is working here on Manic. My input, as I'm on the bottom channel here, normals from the top channel, and that's the 5V signal that's normal to the input. So I have my 5V input here, giving the slider a source to actually bias and offset with, and I'm bringing my low pitch sine wave, this green trace and green cable, into the modulation input. We're first coming out of the clean output, so you can see what's happening, and that will be the yellow trace and it's the yellow cables, and the blue trace there just indicates 0 volts on the scope. As I turn up the mod, this just turns up the level of this low-pitched sine. We can invert it, and you want to be set to be bipolar with the VCA mode here. If you're unipolar, you'll actually half-wave rectify this sine wave, and well, that's fun in itself, and you can use the bias there to offset it. To properly get the wave coming through, set the VCA to be bipolar, and then the bias slider will actually push this waveform up and down to offset your signal. Now taking that into the shape output, let's first have a quick look at clipping, so that can be fun too. So we're clipping our sine wave at the mod input now, and the bias acts like a PWM. So you could actually plug an LFO in there and get PWM-like effects. Let's change to folding. And that bias is working as a symmetry control, where we could see that sine move up and down before it pushes into more positive or negative folding. So that's how to add a symmetry control to the folder here, and we can do this in stereo. So modulation into the top channel, normaling down, this is my audio rate sine wave we've just been listening to. Blue and yellow traces now as hard left and right signals. Let's hear this as a stereo symmetry offset folder. And one interesting thing here, as the modulation is our audio source, if we make these VCAs unipolar, we'll half-wave rectify. We see these interesting 0 points in the waveform to get this lovely kind of PWM effect. Which is definitely something I'll be exploring more of. If you got this far in the video, drop a hard sync in the comments. We're really just scratching the surface of what Manic can do here, and we've got lots of future videos to come exploring its functions in various musical ways. In the next one, we're going to look at the bipolar VCAs and ring modulation, as I think it's a highly underrated tool for lots of interesting things. If you have questions about Manic or requests for patches, let us know in the comments, and that can help shape future videos. You can support me on patreon.com/DivKid, hit like and subscribe. Thanks for watching. Bye bye.